What is electromagnetics? Electromagnetics is nothing but it's a study of charge. In this picture, we have a charge and its velocity is zero. Then such type of charge is known as static charge. This charge is kept at origin, and what is the tendency of charge? It radiates electric field lines or it emits electric field lines. Can we say these electric field lines are present in the free space? Means this electric field will be the function of x, y, z because these are the spatial coordinates. It means that the electric field is the function of x, y, z means electric field is present in the space only. Means we can conclude here that any static charge produces a static electric field. What is a static electric field? A static electric field, if any field is the function of space only, then we say it's a static electric field. For example, E is the function of xy. Is it a static field? Answer is yes, because it is the function of space only. Magnetic field is the function of x, z. Can we say again it's a static field? Yes, answer is yes, because this magnetic field is the function of space only. What we conclude from this figure, any static charge means velocity is zero. Any static charge produces a spatial electric field, or you can say any static charge produces a static electric field. Let's take another condition. Now we have conductor. In this conductor there are enormous amount of electron, and this conductor is excited by some source. Then what will happen? After getting energy, electron will move. Suppose that electron is moving in this direction, the current will produce in opposite direction. You can notice here this is a DC source, and because of DC source a DC current is producing. What is the nature of this DC current? If you plot the graph here, this current is constant with respect to the time. What do you mean by it? It means that current is produced because of the motion of the charged particle. If this current is constant, it means that velocity of the charged particle is constant. Means finally we can conclude, if charged particles are moving with constant velocity, they will produce current, and because of current a magnetic field will produce. We can say this magnetic field is present in the free space, as well as what is the nature of this magnetic field. This magnetic field is forming a closed loop, means magnetic field will always exist in the form of closed loop. We can conclude that DC current produces a static magnetic field. DC current produces a magnetic field which is the function of space only. If any field is the function of space only, then we say it's a static field. So we can say this magnetic field is a static field because it is the function of space only. Here I have written any type of current will produce magnetic field. There are two types of current. One is conduction current, another one is displacement current. What is conduction current? The current flows through the conductor is known as conduction current. A current flows through the dielectric material is known as displacement current. Please remember these two lines. What is the nature of current here? It's a conductor. This current is flowing through the conductor. It means that it is a conduction current. In this case, remember that the velocity of the charged particle is constant because of the constant velocity of the charged particle, a DC current will produce. Because of DC current, this DC current, magnetic field will produce, and the nature of this magnetic field is static because it is the function of space only. So I have explained here the concept of magnetic field, and the root cause of magnetic field is current, and this current may be conduction current, this current may be displacement current. I am giving the some uh, basic concept of displacement current. Okay, so I have a capacitor. I have a capacitor, and in any capacitor contains two metallic plate, and these metallic plates are connected with wire. Okay, this wire is nothing but it's a conductor. Through the conductor, which type of current flows? Conduction current flows. Because of current, which type of field will produce? Magnetic field will produce. And magnetic field will always exist in the form of closed loop, always remember. But between these two plates there is dielectric material, and if you put a compass here, if you put your compass here, the needle of this compass will deflected. If this needle is deflecting or fluctuating, it means that magnetic field is present. And recall that what is the root cause of magnetic field? The root cause of magnetic field is current. Means there is some current between these two plates which is flowing through the dielectric material. It means that a current which flows through the dielectric material is known as displacement current. Again, I am explaining this concept. This is your compass, this one is your needle. If you put your compass here, needle will be deflected. Needle will be deflected means there is presence of magnetic field. It means that what is the root cause of magnetic field? Current. Means there is a current which is flowing through the dielectric material is known as displacement current. We can understand this displacement current by this figure. You can notice here there are two antennas. Antenna is nothing but it's a metallic structure. What is the function of this antenna? It produces radiation, or it produces electromagnetic wave. There is electric field, there is magnetic field. Magnetic field is present in the free space. If magnetic field is present in the free space, it means that what is the root cause of magnetic field? Current. Means current will exist between these two conductors. Means this type of current is nothing but it's a displacement current. Can you compare with this situation? It's a conductor, this is the one conductor, it's another conductor, this is another conductor. Between these two one there is dielectric, between these two one there is free space. Through the dielectric, which type of current flows? Displacement current flows. Through the free space, which type of current will flow? Displacement current will flow. So hopefully you have got the concept of displacement current, but always remember the root cause of magnetic field is nothing but current. It may be conduction current, it may be displacement current. Okay, now so far we have seen the two situations. If velocity of the charged particle is 0, then we say it's a static charge. Static charge produces a static electric field. If velocity of the charged particle is constant, then it will produce current, and because of that current, a magnetic field will produce. That magnetic field is a static magnetic field, but remember that velocity of the charged particle is constant. Now in third situation, we will vary the velocity with respect to the time. If velocity is varying with respect to the time, it means that it's an acceleration. And always remember, accelerated or deaccelerated charge produce a radiation. This concept we can understand from this diagram. This is your antenna. Antenna is nothing but it's a metallic structure connected with source. This part is known as transmission line. And through the conductor, which type of current flows? conduction current flows. What is the root cause of current? Current will produce because of the motion of the charged particle. At this point, assume that there is some velocity of the charged particle. Okay. At this point, the conductor the conductor is ended, or after that there is no conductor. What will happen? Electron will move in this direction, but these electrons which are moving here, they cannot cross the boundary of the conductor, means they will not go in free space. Then what will electron do? The electron will reduce its velocity. At this point, velocity of the charged particle will become zero. The reason behind it, because electron cannot cross the boundary. There is some velocity of the electron. At this point there is zero velocity. It means that electron is reducing its velocity with respect to the time, and we can say if any charge particle, if any electron is reducing its velocity with respect to the time, it means that it's a deacceleration. Or I told you कि any accelerated or deaccelerated charge will produce radiation. Can you understand the phenomena of acceleration or deacceleration on the structure of the antenna? At this point there is some velocity of the electron. At this point velocity will be zero. Why? Because electron cannot cross the boundary, means electron has to reduce its velocity, and velocity is varying with respect to the time, or velocity is decreasing with respect to the time, means deacceleration, or an accelerated or deaccelerated charge produce radiation. So hopefully you have got the concept of electric field, magnetic field and radiation. Actually we are studying the charge. This is nothing but it's a electromagnetic, but always remember we can understand the problem of electromagnetics with the help of some tool. So first tool is coordinate system, second tool is your vector calculus, third tool is E cross H rule, fourth one is Maxwell equation, fifth one is phasor and how to write the equations, sixth one is wave equation. These are the basics of the basic tools. Firstly you have to understand these tools, then you can understand the electromagnetics. Hopefully you have got this lecture. Thank you very much.